So in question 17 we are doing some circuit analysis. So the first thing to do, part A basically, is what's going to happen when the switch in the circuit is open. So there's a couple of things about circuit problems. Firstly, you need to look at the circuit diagram as well as the question to get all of the quantities you need if you're using an equation. So some of the quantities that we need are actually on the circuit diagram, the 6 volts up here. The other thing that's really helpful when you're doing an analysis of a circuit is to just identify if it's a series or parallel circuit. And whilst the switch is open, so for A, we've got a series circuit. And when the switch is closed in B, you've kind of got a parallel section in series with that resistor. So it's kind of we've kind of got a parallel circuit going on. So let's start with part A. So we've been told the lamp and the resistor each have a resistance of 5 ohms. So maybe I'll just label those onto the diagram. And their combined resistance when the switch is open is 10 ohms. Even if they hadn't have told us that, we could have worked it out, because when you have components in series, you just add their resistances together. So it would just be 5 plus 5 equals 10. Okay. And we've been asked to use the data sheet to calculate the current in the circuit when the switch is open. Okay. So we've got current, we've got the total circuit resistance, that's what we need to use, and we've also got the potential difference from the battery. Okay, so we've got V equals 6 volts, we've got the total circuit resistance R equals 10 ohms, and then the current I is our question mark. Okay, so we're effectively doing quens. I'm just not going to write the Q-U-E-N-S down the side. The next thing is to select the correct equation from the formula sheet. So I'm going to go to the electricity topic, and I want an equation with V, R and I in. So you can see that is this one here, V equals I times R, potential difference equals current times resistance. So I'm going to write that underneath, V equals I times R. I'm then going to put all the values in that I know. So, well, before I do that, I'm going to double check my units. We're in volts, not millivolts or kilovolts, so I'm happy with that. And I'm happy with ohms as well. So my units are fine. We're then writing the equation down. Then we're going to substitute the numbers into the equation. So the n from quens, which is going to be 6.0 equals I times by 10. And then to find I, we're going to divide both sides by 10. So that means I equals 6.0 over 10.0. And when you put that in your calculator, you should get 0.6 amps. Okay, so that's the first part. We've also been asked in part B, so part A is calculate. The command word is calculate, so we're basically using quens. Okay, for part AII, we're state the potential difference across the resistor when the switch is open. Okay, if you're stating a value, it normally means that the calculation is very simple, or it's something you should just be able to kind of work out without actually having to do much of a calculation. So there's a few ways to think about this, but what I'd do is think about, well, we've got a series circuit. So we've got a resistor and a bulb in series. They both have the same resistances as each other. And when you have components in series with each other, the potential difference from the power supply is split, it's shared between the components. So the potential difference on this, the resistor and the bulb, have to add up to 6. And they split based on the resistances. And if the resistances are equal to each other, they split evenly. If they're not equal, then the one with the higher resistance will have a bigger share of the 6 volts. Okay, but when you add them together, they will always add together to make 6. Okay, so that's voltages or potential differences in a series circuit. So state the potential difference across the resistor when the switch is open. So when the switch is open, basically these two components are going to share that potential difference evenly. So it's going to be half of 6 volts on each. So the potential difference across the resistor will be 3 volts. Okay. The next part of the question is what happens when you now close this switch. And effectively, if you close that switch, you've created what we call a short circuit. Okay, you've made a path for the current to flow around this 5 ohm lamp. And because we generally consider wires to have negligible resistance, basically so close to 0 that we can ignore their resistance. Because this has got almost 0 resistance, basically all of the current is just going to be able to flow through this wire. You're not really going to get any current flowing through that 5 ohm resistor. Okay. So describe how the current through the resistor changes, through the 5 ohm lamp. So what's going to happen to the current here if you close that switch? Well, if you close the switch here, suddenly the resistance of these two is almost 0. It's, for practical purposes, the resistance of these two combined becomes 0. So the total circuit resistance has gone from 5 plus 5, which is 10, to basically 5 plus 0 ohms when you close that switch. Okay, so the total circuit resistance is halved. So the current flowing through this resistor now, because you've halved the resistance, the current is going to double. Okay, you'd now have 6 divided by 5 rather than 6 divided by 10, so it's going to be twice as big. So how do we put that into words? Describe how the current through the resistor changes and explain. So first of all, describe how it changes, so what happens, and then we need to explain why. Okay, so what happens? The total resistance, the current in the resistor increases. So describe how the current changes. The current increases. It basically doubles, but we can just say increases. Okay, so the current increases. Why? So explain your answer. Because the total resistance of the whole circuit has decreased. It's gone from 10 ohms to about 5 ohms. Current increases because the total circuit resistance decreases. Okay. Describe how the potential difference across the resistor changes. Explain your answer. So we've already determined that the current in the resistor increases because the total resistance of the circuit has gone down, so we can get more current flowing. What happens to the potential difference across the resistor? And again, we need to explain our answer. Well, if you go to the the 5 ohm and the resistor and the 5 ohm lamp, when the switch was open, remember, we had 3 volts and that one would have been 3 volts as well. They have to add up. If we put, these are voltmeters here, they have to add up to 6 volts. Okay, so we get 3 volts across each. When you close the switch here, the resistance of this part basically becomes 0. So the potential difference across it becomes 0. Okay, and the potential difference across here, well, they still have to add up to 6. So that will go from 3 volts, and it will go up to 6 volts because 6 plus 0 equals 6. So that will become 6 when you close the switch, and that will become 0 because when you close the switch, that basically has no resistance, that part there. So describe how the potential difference across the resistor changes. The potential difference also increases because the resistance of the lamp and wire equals 0 ohms when switch closed. There's another way of thinking about the same thing, which is that when you close the switch, we already know that when the switch is closed, the current flowing through the circuit increases, okay, basically doubles. So because this resistor has a bigger current flowing through it, well, if you double the current flowing through it, then actually you're going to double the potential difference across it, because remember that potential difference there, V equals IR. So if the current is twice as big with that switch closed, the resistance of the resistor is still 5 ohms. So if you double the current, then you're going to double the potential difference. So that's another way of explaining the same thing. You could say that the potential difference increases because the current flowing through it increases. Final part there, state the potential difference across the lamp when the switch is closed. When you close the switch, because these two in combination, their combined resistance is 0, that is going to become 0 volts. Okay, and that's going to become 6 volts when this is closed. So potential difference across the lamp is going to be 0.